Your API is not an MCP server. I saw this tweet the other day and I wanted to record a response explaining why MCP is not just an API, point out how this is missing context, and basically I want to give you a very robust explanation so that this meme is inverted. I'm going to defend this position with enough strength to fend off all these naysayers. And to be clear, this isn't anything to do with the person who wrote this. I've seen this sentiment come up a few times, and if I'm truly honest, a few weeks ago I was going more in depth into MCP for the first time, and I had a similar question, but I've done the work to really clearly explain what's going on here so that you can learn as well. The issue I have with this type of tweet is that it lacks any context, such as what we're trying to do here. Well, within the context of MCP, what we're trying to do is provide agents with the necessary context and tools to autonomously perform tasks to a high standard. Suppose MCP doesn't exist yet. Suppose we only have an API. Let me run through that scenario and explain some of the stumbling blocks you would fall into, and then that will set up the stage so we can explain how MCP soothes some of those qualms and difficulties. What is an API? Well, API, you could interpret it very broadly. I think that's what's going on here. But generally, it's used by developers to enable different software systems to communicate and interact with each other. You build, or someone else builds, a server, and it publishes a set of custom endpoints, usually following a style like REST. I'm not going to explain this in any depth because it's something you've seen 100 times. For example, the GitHub API. The key point here as it relates to using agents is that an API is not a specification. It's not a protocol. It's up to whoever builds the server to decide what endpoints they're going to implement, what parameters they take, what authentication scheme, how complete and rigid or structured is the documentation. We don't know. I accept that a lot of servers do expose an OpenAPI schema today, and we will come back to that because it is relevant to building MCP servers. However, it's not an obligation. And in a world where we want to empower autonomous agents, well, we can't rely on this stuff being there or not. Like, we need something a bit more structured. The task then becomes that you want the agent to interact with the outside world. So say MCP is not a thing and you want your coding agent to make a pull request on GitHub for you. You could, I suppose, give the agent a HTTP tool, and then you give it a link to the OpenAPI schema and a link to some documentation, and maybe the agent figures out how to do that. And that probably was a thought experiment at some point, but it doesn't make any sense. It would be very slow and unrepeatable. And so what ends up happening is people start building tools specifically for different APIs. And this leads to an MXN problem where for 5 different services, you need 5 different tools. And it gets worse actually, because when you build a tool, you express that in a programming language like Python or TypeScript, and then you're importing it into your agent. But if the agent is coded in a different language, now you need to think about building these tools in different languages, and it all gets very like boilerplatey and cumbersome for no reason. And back in this kind of era when people were building their own tools, and even today if you were to attempt it, you'd kind of have to figure out best practices, like how to structure the tool in such a way that an LLM can easily make use of it. There was no real guidelines and the quality of tools varied a lot. And so if API is not really a protocol or a specification, the LLM has to do a lot of work to figure out what's going on or rely on a tool and still maybe get it wrong sometimes. MCP is a strict protocol. All protocols are strict by definition, designed to be used by models, and it standardizes how they discover, describe, and interact with external tools and data sources. This is really important for querying data to put in the context window to give the agent better information to go off of. It's also really important if you want the agent to be autonomous and take some action. That's typically going to involve interfacing with an external system, be that a server or something like that. So it's a protocol, huh? What does that mean? Well, whereas with an API server, pretty much a dealer's choice how you go about it, MCP requires someone implementing an MCP server to do specific things. For example, it's crucial that an MCP server supports self-discovery by publishing a machine-readable catalog of all of the things it can do. This enables an agent to go to an MCP server and basically ask it, hey, what information do you have? What stuff can you do? And that will enable it to acquire skills, if you like, and make the next best move. What kind of stuff does a MCP server expose? Well, the key ideas are that it exposes tools, which are how we represent actions for things like API calls. And it might be an API call, by the way, but it could also be some kind of workflow, for example. An MCP server can also expose resources and prompts and some other things. We won't get into all of that. The key point is that anything you need to access or anything you need to do, you go through one of these predetermined mechanisms, and they're designed specifically for LLMs. So the key differences here are that MCP is model friendly. It produces a uniform and predictable schema. This means the LLM doesn't have to work to figure stuff out. It means less chance of things going wrong. It's self-describing. It has structured inputs and outputs. And it also, by design, tends to have a more minimal surface area. Tools, resources, prompts. It's fairly predictable. And basically, models, the more you give to them, the more likely they are to go wrong by their nature. They are not deterministic, and they have a limited context window. Again, I do acknowledge that there are some similarities here, and I think this is where things get particularly muddy and confusing, because what you'll often see, and especially in recent months, a bit less so now, but what you would often see is that a lot of MCP servers were basically wrappers around APIs. And if that API had an OpenAPI schema, if your intuition was telling you, well, I could programmatically generate an MCP server and a bunch of tools for each endpoint, you would be spot on. And in fact, there are tools like Smithery that do this for you. And frankly, it could be a good starting point. It might even be okay, but you should be aware of some of the challenges and some of the opportunities. Here's an example from Stripe where, as you can see, each tool pretty much corresponds to a different API endpoint. There's a few problems with this, and this is especially true if it's auto-generated. The first is that API documentation is basically designed for developers. We can interpret vague documentation and read between the lines. Frankly, if the documentation was so explicit, ignoring the fact that we're experienced and we have 10 years of experience, we would find them incredibly tedious and laborious and difficult to scan. But an LLM shouldn't really be left to assume anything. And so you would need to create specific descriptors and documentation for tools. And you can express these in interesting ways. For example, here's Sentry's MCP server, and you can see the tool description is specifically made for a large language model to discover and use. We see some familiar stuff if you've done any prompting, like these do not use this, do not do that. Examples are so important. Developers, we can kind of intuit and we can poke around. We can look up something on Stack Overflow. We know what to ask ChatGPT to see things come together. But a model really benefits from specific examples to produce the best output. And so we need to tailor our tools for models. And I grant you, you could create an equivalent tool for every endpoint that you have and go ahead and create a custom description. That would be a great start. And by the way, if you're doing that, you should also make sure to improve your error messages, because when you return an error from a tool, ideally that error is going to contain some kind of clue to the model, what went wrong and what to do next. If you just give it a stack trace or some generic error or whatever, now it has to go and figure it out. You're increasing the likelihood that it could drift and go off course. And that might be a bad experience for your users, but you can solve that. You can write good descriptions, you can return good errors from your tools. But even if you did solve that, if you are mapping every endpoint to a tool, you're going to run into another problem, something that's quite prevalent actually. LLMs get overwhelmed by a lot of tool calls, and don't take my word for it. Notion is quite a prolific example where they built an early MCP server, kind of capitalizing on the trend, and they ended up rebuilding it because the original server, which mapped created a one-to-one API mapping, led to a clunky agent experience where it would do too many calls, too much token waste. We see this time and time again where the agent just can't pick the right tool. It's a bit like giving a mechanic an enormous toolbox when all they need is a spanner. They're going to get overwhelmed rummaging through all the tools, and then they're going to find two tools that can do the same thing, and now they have to think, oh, which one of these do I use? And when a model ends up in that position, it just tends to implode, basically. It makes sense. It's to do with the nature of LLMs. Like, for it to decide what tool to use, it needs to consider all its options. And it's really interesting stuff. Accepting that this is a problem, we also accept it needs a solution. And there are a few different approaches. One thing I've seen, and to Smithery's credit and other tools which convert OpenAPI schemas to MCP servers, they give you some tunability, right? So you don't have to expose every endpoint. You might pick and choose and reduce the surface area a little bit. That might help. I've also seen GitHub release something interesting for their their MCP server, which is a mechanism for dynamic tool selection. Their product is so vast, right? They have so many different endpoints. I don't think this is how it works, but someone suggested a cool idea, which is that you could filter the tools based on the scope of the token. So there's no point the model choosing from tools to do with like GitHub Actions if the token doesn't even have permission to do that. And there are a few kind of ways of thinking about this. Another, which was highlighted to me in this workshop with Daniel, is that sometimes instead of creating like 4 different tools to create, read, update, and delete, you can create one tool which accepts an argument to do those operations. Or maybe it's a tool that takes some kind of query language in order to manipulate or query the data. The agent might be better at that. And if that sounds a bit wishy-washy and like, well, you want to know what is the right approach, unfortunately, with a lot of these things, it does depend. But the point remains, these are specific considerations you have to make for tools, and this is very different from how we think when we build and consume APIs. The other issue, of course, is that APIs return JSON payloads, and these can be enormous, actually. Models aren't great at this. They are trained and designed to work with natural language. Notion also released, I think they called it Notion flavored Markdown. I think originally they were using a JSON output similar to their API, but they realized they needed a different approach. This is something that you would do specifically for agent compared to an API. And there is this issue of like the context window getting fuller. Basically, there's only so much information the model can see at any given time. And if you're dealing with massive JSON payloads and you need to track them all to remember what happened before, the context window can reach its upper limits. And even though context windows have increased in size, we're also aware of this problem called context rot, by which most of that window is not practically useful. As you reach the upper limits, the performance of the LLM can degrade. So it's something that you really need to consider and build specifically for agents. There's also this issue I mentioned before around workflows, where basically if you know the context that your service is being consumed, which is a user giving an agent a task, you might be able to create tools that encapsulate those type of workflows and produce more predictable and better outputs for people. So I think this idea of turning an API into an MCP server, it's the same write once, run everywhere, which never works. When you build from scratch, you get this opportunity to build things from first principles for an MCP server. And this is the new world we live in, where doing something like that is totally worth it. This might include, by the way, things that your API does not. API endpoints and REST, there's no verbs, right? Like you don't call a function or something, or a workflow necessarily, but with an MCP server, you might. And that's a really cool opportunity, I think. I think we need to move away from some of this sort of like hot take stuff that doesn't make sense, because honestly, we're engineers. I often compare what we do to what architects do. And if you build a skyscraper without really considering the context and the details, it's going to fall over. And we need to treat our discipline with the same level of care and professionalism. And I think that's where some of this consideration comes into play. I can accept that both of them broadly provide a way for one system to access another system's functionality or data. Sure, if that's your definition of an API, fine, but it's not a useful definition. And as you can see, there are some opportunities here. If you want to build your own MCP server, I'm going to level with you. Mastra does provide that support, and it can make a lot of sense to use if you're also building an agent. I won't be upset if you just want to use the official TypeScript SDK for Model Context Protocol. I think that's absolutely fine. It's a great product. If you want to learn more, these are 3 videos that I watched that really helped enlighten things for me. Here's David Kramer of Sentry, who built Sentry's MCP server. I forget this person's name, but they're one of the best lecturers I've ever seen talk about MCPs versus APIs. And here's somebody, David from Neon, who goes on to also give a great example of their MCP server, whereby similar to Sentry's, where I showed you the descriptors, they have a similar approach, albeit a little bit different. And they also have this cool feature where you could prepare and complete a database migration. This is something that their API does not support, but they recognize as being very useful for developers when used within an agent environment. So yeah, check those out, and make sure to check out the Mastra YouTube channel as well if you're looking for more videos like this that bring some perspective and a nuanced explanation to things. I've been Alex Booker and Mastra. Thank you so much for watching.